you watched this video, I sure hope you've done the Desmos activity because that'll make the notes, they'll resonate more in your brain and your learning will be stronger. So in this video, we're going to talk about transformations of exponential functions. If you did the Desmos exploration, these notes should be really, really fast. So there's the parent transformation, the parent exponential function that gets transformed. It gets transformed according to this rule. So remember, parent, let's just call parent g of x. G of x is equal just to base to the power of x. It gets transformed. That means it gets translated and it gets dilated and reflected, and you get this function f of x. And the transformation rule is f of x is equal to a times the base to the power of c times x minus h plus k. That's the transformation equation. And we're going to go through each of these transformation parameters one by one and see how it impacts the graph. The first transformation parameter that we're going to look at is k. So it's right over here. Notice where k is in the equation. K is the constant that's being added at the end. So k is constant being added or subtracted at end, plus or minus at end. Or it could be at the start. But it's separate from the exponential term. Okay, so it's just a constant term. So maybe that's a better thing. It's just a constant term. Constant term and separate from the exponential term. That's how you can find k. And if you did the exploration, k is vertical translation. And you could see like 2 to the x, the plus 3 translates the graph, the parent function 2 to the x up by 3. 2 to the minus 3, or 2 to the x minus 3, that translates the graph down. So every single point moves up by 3 or down by 3 or up by k or down by k, whatever k is. The impact, it moves the horizontal asymptote, that moves with k, and it also moves the y-intercept. So what does it impact? It changes the y-intercept. The y-intercept becomes k, and then it changes the horizontal asymptote. And the horizontal asymptote, it moves with k. So k is pretty nice, or vertical translation. The next transformation parameter is h. And let's find h in the equation. So h is right here. And h is up there in the exponent. Notice a couple of things about h. H is being subtracted from x. Subtracted from x. And notice that x has, when x has a coefficient of 1. That is how you find x. So x minus h, in the polynomial unit, we'd say that x minus h is a proper factor. So you want, in that exponent, you want a proper factor, x minus h, and h is the horizontal translation parameter. So notice here is f of x to the 2, f of x equals 2 to the power of x. If we subtract 3 from x there in the exponent, that shifts the function 3 units to the right. Every single point on the function translates 3 to the right. If we add 3 to x, that's like 2 to the x minus negative 3. Everything on all points on the graph shift 3 units to the left. So there are our y-intercept changes. Horizontal translation causes a change in the y-intercept. The horizontal asymptote stays the same. All the points translate 2 points, or they translate with h. Next we have the transformation parameter a. And a is the absolute, so let's find a in the equation. So a is right here. And A is, where is A? A is multiplying the base. Multiplying base. So it's multiplying the b times c to the x minus h. Okay, so it's that number. It's like that coefficient of the base. And the absolute value of that parameter A is the vertical dilation. So that's your vertical stretch or compression. If the vertical, so here we have f of x is equal to 2 to the x. If our parameter A is 3, that vertically stretches the function, so it goes up faster. If the absolute value of A here is 1/3, so 1/3 times 2 to the x, then you can see the function is going up more slowly. It's been vertically compressed. So that is A. That is your vertical, the absolute value of A is your vertical dilation. Then we have the sine of A. So once again, we're working with A, and A, it's like the coefficient of the exponential term. It's multiplying that base. The sine of A indicates what vertical reflection. So if A is less than 0, then the function gets reflected vertically across the x-axis. So f of x is equal to 2 to the x here. If we multiply f of x by -1, so in this example, A is equal to, let me change it to red, A is equal to -1, the function gets reflected across the x-axis. What changes? Well, the horizontal asymptote doesn't change, but it looks all the point coordinates change. The y coordinates change, the x coordinates don't. So changes the y coordinates of all the points. Flip their signs. The horizontal asymptote stays the same. One more transformation parameter, and that is c. So where in the heck is c in this equation? C is right here. Notice that C, its location, let's describe it. C is multiplying, it's in the exponent. So in exponent, and it multiplies x minus h. It multiplies that proper factor, or that proper factor x minus h. So the sine of C, it tells you, it controls horizontal reflection across the y-axis. So here's our parent function, f of x equals 2 to the x. If we multiply that x, if we put a negative in front of it, so c is equal to -1 here, that reflects the function across the y-axis. So multiplying x by a negative, that gives you a horizontal reflection. If you multiply y by a negative, or the output by a negative, that exponential by a negative, that gives you the vertical reflection. So that's A, C, H, and K. Those are your transformation parameters. And those are the the only four numbers you need to transform to come up with any possible exponential function directly from the parent function. So the power transformations, you just need four numbers, and you can take that exponential function to any other conceivable exponential function, which is pretty cool. Next video, I'm going to show you how to graph using transformations. Bye.